Good morning, students. Now we'll see. You know the amplitude modulation technique, frequency modulation and phase modulation, right? Now you know the complete behavior of the analog modulation techniques. Now you just see all the modulators of AM, FM, PM and all the demodulators of AM, FM and PM. Now my question is, now how that AM signal is received? So we are transmitting the AM signal, it is transmitting through the channel and it will be appear at the input of the receiver. Now my question is, now the AM signal is appear at the input to the receiving antenna. Now the receiver is directly recognize the AM signal, but there are so many signals are coming, AM, FM, PM, voice signal, data signal, right? N number of signals are transmitting through the channel, but how your receiver is exactly recognize your signal. Okay, so now we'll see the receiver designing. Okay, transmitter is nothing but which is already modulator part and transmitter, what are the components, everything which we are completed. But the receiver is important because so many signals are coming. If you only one signal, there is no other option, definitely it will receive. But my question is, out of n number of signals, how your receiver is select, is track, is getting only your signal. Okay, and how it is rejecting all other unwanted signals and how it is selected only the wanted signal is the designing of a receiver. Okay, now we'll see both FM and AM receivers. Now before forget about AM and FM, now what should be the receiver and what should be the characteristics of a receiver. Okay, now first of all I want to concentrate on characteristics. Characteristics of a receiver. Okay, now the characteristics of the receiver, first one is sensitivity, second one is selectivity, and third one is fidelity, and fourth one is, this is not the characteristics up to here. Okay, now first we want to discuss all these characteristics, then we go for actual designing process of AM and FM receiver. Okay, now sensitivity, selectivity, fidelity. Okay, right, now you tell me what is sensitivity. What is sensitivity? Okay, now my question is, now let us take an AM signal. Okay, now AM signal is transmitting by the transmitting antenna with a power of 100 watts. Okay, with a power of 100 watts. The signal strength, the power of 100 watts is transmitting through the transmitting antenna. Now that AM signal is transmitting through the channel, right? Now because of the various losses in the channel, absorption losses, attenuation, distortion, scattering, bending, so many losses in the channel, then that 100 watts is strength is decreased and it just a 0.1 watt signal strength which is appear at the input of the receiver. But what is the actual strength? You are transmitting 100 watts, but how much you are received at the receiving antenna is just 0.1 watt. Okay, so now my question is, just 0.1 watt signal is received by your receiving antenna, but actual strength is 100 watts. Now your receiver in a position to receive that signal, sense that signal is the important point here. Even if a minimum signal strength is coming at the input of the receiver, your receiver in a position to recognize that signal, that characteristic parameter is called as sensitivity. That characteristic parameter is called as sensitivity. What is the sensitivity? The minimum signal strength, note down, the minimum signal strength that should be applied at the input of the receiver to get the standard output. The receiver in a position to sense the minimum signal strength which is appear at the input of the receiver and in order to produce a standard output. Okay, the sensitivity is defined as a minimum signal strength at the input of the receiver to get the standard output. Now this is receiver 1. And this is receiver 2. that is receiver 1 and this is receiver 2. Now this is the signal strength is 10 watt and here the signal strength is 0.1 watt. And the standard output is 1000 watts and height the standard output is 1000. Okay, now see here, the signal strength which is appear at the input of the receiver is 10 watt and produces the standard output of 100 watts. The signal strength which is appear at the input of the receiver is 0.1 watt and produces a standard output of 1000 watts. But here the minimum signal strength which is coming 0.1 watt, but which is the sensing, which is the receiving, which is the recognizing, and in order to produce the standard output. Now you tell me which receiver is more sensitive. Receiver 2 is more sensitive than receiver 1. What is sensitivity? The sensitivity is defined as the minimum signal strength which is applied at the input of the receiver to get the standard output. Okay. So, but what the sensitivity is depends upon what? Yes, both are sensitive. The receiver 2 is more sensitive than receiver 1 and both are producing the standard output but receiving of 0.1 and receiving of 100. So now you tell me the receiver sensitivity is depends upon what? Now here the gain is 10. Here the gain is 10,000. Now this is 10,000 into 0.1 which is equal to 1000. 10 into 10, sorry, this is 100 into 10 which is equal to 1000. Which is, what is the meaning of that? The meaning of that is here, now see here, the sensitivity is completely depends upon gain of the receiver. Okay, what is the meaning of that? So sensitivity depends upon gain of the receiver. Sensitivity depends upon gain of the receiver. Okay, the sensitivity depends upon gain of the receiver, which means if the receiver gain is more, if the receiver is having high gain, if the receiver is having high gain, means more sensitive. If the receiver is having high gain, means more sensitive. Clear or not? Right? No doubt. Okay, so what type of characteristics your receiver should have? So we always have a receiver is having a good sensitivity, means the receiver gain should be high. Okay, now this is the one of the characteristics of the receiver, which is nothing but sensitivity. Next one is selectivity. Now this is, I think you are familiar. Okay, now the first block of any receiver is nothing but Now what is the output of the transmitter? The output of the transmitter is a modulated signal. Is it right? Not. A modulated signal means it is having a carrier frequency and upper sideband, lower sideband, upper cutoff frequency, lower cutoff frequency, some pass band. Am I not? So it is a band of frequency. Therefore, now first of all, the first block of any receiver, it should be a band pass filter. Why? Because it will allow a band of frequencies having some center frequency, having some resonant frequency. Am I not? So which means that the band pass filter is having a specified characteristic, specified pass band. So the first block is nothing but filter. The filter whose job is, the filter job is to select the required one or to select the to reject the unwanted one. Okay. Now the selectivity, which is nothing but ability of the receiver to select the required frequency component. Note down, selectivity means ability of the receiver. Selectivity is defined as ability of the receiver to select the required frequency component or ability of the receiver to reject the unwanted frequency component. Okay. So generally the selectivity is done, selectivity is depends upon type of filters. You want a low frequency signal, low pass filter, high frequency signal, high pass filter. You want a band of frequencies, so band pass filter, like that. Okay. But the selectivity is ability. It is having an ability of a receiver to select the required frequency component and a ability of the receiver to reject the unwanted frequency component. Okay. Generally the selectivity depends upon filters, and generally in all our modulation technique, output is a modulated signal, input to the receiver is also a modulated signal. Modulated signal means a band of frequencies. Therefore the first block should be a band pass filter. Okay. Right. Next one is fidelity. What is a fidelity? Fidelity is defined as ability of the receiver to reproduce all audio frequencies at the output of the receiver. Once again I am repeat. Fidelity is defined as ability of the receiver to reproduce all audio frequency component, all audio frequency spectral components at the output of the receiver. For example, one simple example I am giving. Suppose audio signal is having a spectral component like this. Now F1, F2, F3, F4, F1. This is an audio signal whose spectral components, whose information is distributed over a frequency like this. Right? Now this is the receiver side. Now my receiver is reproducing at the output of the receiver. I can get F1, I can get F2, and I can get F3. That's it. Okay. Now this is output of the receiver. So what happened? The fidelity is defined as ability of the receiver to reproduce all audio frequency spectral component at the output of the receiver, but there are 5 spectral components here, but my receiver is reproducing only 3 spectral components, and this spectral component and this spectral component is missing. So which means here what happened? Now which means fidelity is less. Fidelity is not good. So the receiver is not having a good feature, means it is not able to reproduce all the spectral component at the output of the receiver, all audio frequency component at the output of the receiver. Am I not? Fidelity is not good. If I am able to reproduce all audio frequency component, then fidelity is good, which means the quality of the audio signal, okay, is depends upon this particular fidelity. Note down. Fidelity is the audio signal quality. Fidelity is defined as ability to reproduce all audio frequencies at the output of the receiver. Okay, fidelity is defined as ability of the receiver to reproduce all audio frequencies at the output of the receiver. Note down. Clear? Now here the fidelity topic itself, now we find one small points here also. The highest audio frequency, the highest audio frequency that will be reproduced at the output of the receiver in amplitude modulation is 5 kHz. The highest audio frequency that will be reproduced at the output of the receiver in amplitude modulation is only 5 kHz. Okay, but what is audio signal component? In audio signal spectrum, then the audio signal is of 20 Hz to 20 kHz. Now this is the audio frequency range. Now this is the audio signal, but in amplitude modulation, in AM, in amplitude modulation, the highest frequency is only 5 kHz. Up to 5 kHz part only received, and remaining part is not ability to reproduce. Okay, the highest audio frequency is only 5 kHz. Therefore, this is omega, which is equal to 5 kHz, the highest frequency. Then what is the bandwidth of each AM tuned station? So the bandwidth of AM tuned station, which is equal to 2 omega, which is equal to 2 into 5 kHz, which is equal to 10 kHz. This is the bandwidth of each AM tuned station. Okay, note down. So in AM the audio signal is band limited to 5 kHz. In AM the audio signal is band limited to 5 kHz. Therefore, the bandwidth of each AM tuned station, which is equal to omega, which is equal to 5 kHz, 10 kHz. Okay, each in audio signal is band limited to 5 kHz. Therefore, bandwidth of each AM radio station is, or each AM radio station is having a bandwidth of 10 kHz. Clear or not? Okay, now done. Okay. Now for example, now in place of AM, then this is FM. Okay. So in FM, almost all audio frequencies are reproduced. In FM, all audio frequencies are reproduced. In FM, all audio frequencies are reproduced. All audio frequencies are reproduced in FM because the fidelity is very high in FM because the effect of noise is less in FM. Now why AM audio signal is band limited to 5 kHz? Because the effect of noise is more, fidelity is less in AM. Okay, so the highest, the audio signal band limited to 20 kHz. The audio signal band limited to 20 kHz. Therefore, all audio frequencies are, almost all audio frequencies are reproduced at the output of the receiver, and bandwidth of each FM radio station, is having a bandwidth of 200 kHz. Each AM station is having a bandwidth of 200 kHz. Okay, so fidelity is high in FM transmission. Okay, no. Fidelity is very high in FM because effect of noise is less. Fidelity is very less in AM because effect of noise is more in amplitude modulation. Okay. Now we'll see another module which is mixer, and after that we'll go for the exact receiver designing process. Okay. Now what is a mixer? Now the mixer here is, the job of the mixer is used in any communication system. The mixer is used in any communication system to change the carrier frequency of modulated signal. Listen carefully. Modulated signal means modulation is done, amplitude or frequency, whatever a modulation is done. That modulated signal carrier frequency, let us say FC. That FC is going to be changed with the help of mixer. The mixer is used in any communication system to change the carrier frequency of the modulated signal. Change means it may increase the carrier frequency or it may decrease the carrier frequency. Now see here. Now this is message signal and this is the balanced modulator, as nothing but product modulator, and this is the carrier signal cos 2 pi fct. Now this is message signal multiplied with carrier signal. Now this is nothing but DSB-SC, double sideband suppressed carrier modulated signal. Is it right or not? Now this is the double sideband suppressed carrier modulated signal. Now M of t into cos 2 pi fct. Okay, just I write here. Okay. Now the carrier frequency is Fc. Now this is the multiplier. Now this is the local oscillator. Now the local oscillator will generate one frequency FL. Okay. Now this local oscillator will generate a frequency FL. Let us assume this FL is greater than Fc. Now what happened here? Now this is nothing but m of t multiplied with cos 2 pi fct multiplied with cos 2 pi fl into t. Therefore, if I multiplied with 2, divide with 2, 2 cos A cos B, cos of A plus B, cos 2 pi fl plus fc into t plus m of t by 2 cos 2 pi fl minus fc into t. Cos A cos B, cos of A plus B plus cos of A minus B. Now m of t by 2 cos 2 pi fl plus fc into t, m of t by 2 cos 2 pi fl minus fc into t. Now see here. Now this is fl plus fc. Now means same m of t spectrum, m of f, right? Now that carrier frequency is fl plus fc. Now see here. Now this is fl plus fc. This is fl minus fc. fl plus fc and this is fl minus fc. Now this is up conversion. Carrier frequency is increased. Now this is down conversion. Carrier frequency is decreased. Okay, so I increase the carrier frequency or I decrease the carrier frequency. Now see here. Now, no sir, I want only down conversion. I don't want up conversion. I want only down conversion. Then not a problem. What should you do? Now this you pass through a band pass filter with a proper characteristics, with a proper pass band characteristics. This is the band pass filter. So you select the required one. Okay. So if I design a band pass filter like this to select the down converter. Now you can get back this signal. Okay. Now this is the band pass filter. So this portion, what is this? This is nothing but, this is the mixer. Now this is the mixer portion. Okay. What is the mixer? The mixer is used in any communication system to change the carrier frequency of the modulated signal. Change means it may increase or it may decrease. Increase means up conversion, decrease means down conversion. So you want to select an up conversion or down conversion. So use an appropriate band pass filter to get back the down conversion or up conversion. Okay. So this is the mixer output. This is the mixer output. Now this is FL minus FC. Okay. So this is FL minus FC, which is called as intermediate frequency, or FL minus FS, which is called as intermediate frequency. What is this? Now this is in down conversion. In down conversion, FL minus FC or FL minus FS. FS or FC both are same. FC, which is equal to FS, which is carrier frequency of modulated signal. Carrier frequency of modulated signal or carrier frequency of carrier frequency of the tuned station. Carrier frequency of the tuned station. Generally, the mixer is used for down conversion because I want to down convert the signal such that the stability problems are overcome. So we generally going for down conversion. Therefore, the purpose of mixer most of the time, not only strictly down conversion, it may be up conversion, but in our communication receiver's point of view, we use the down conversion. Now this FL minus FC is nothing but a down converted signal is called as intermediate frequency. This is intermediate frequency. Intermediate frequency. Yeah. Okay. Now this is the carrier frequency of the modulated signal or a carrier frequency of the tuned station. No doubt. Clear or not? Okay. Now this particular basics is required to understand any receiver, AM receiver or FM receivers or any receiver. Now first we will see amplitude modulation, AM receivers. Okay. AM receivers. So there is an AM or FM in only one receiver. That is nothing but super heterodynamic. And one more point also I am saying. So previously we just see mixer. The mixer is to select the required frequency component. Okay. The process of selecting the required frequency component is called as tuning. Okay. What is the meaning of that? The process of selecting the required frequency component is called as tuning or mixing. That is called as mixing and is also called as heterodyning. What is the meaning of heterodyne? Heterodyne is nothing but mixing of the signal. The process of mixing of the signal to select the required frequency component. The process of select the required frequency component is called as tuning. And the process of mixing the signal, the mixing of the signal is also called as heterodyning. Heterodyning means mixing. So only one receiver which is available, that is nothing but super heterodyne receiver. Okay, whether AM receiver or FM receiver is only one name, super heterodyne receiver. For better understanding of this super heterodyne receiver, now I just explain one receiver, TRF receiver, tuned radio frequency receiver. What is this? Tuned radio frequency receiver. Tuned radio frequency receiver. Okay, TRF means tuned radio frequency receiver. Now first of all we want to have some terms. First of all, now RF means what? Radio frequency, means high frequency. AF means audio frequency, means low frequency. Radio frequency is a high frequency signal. AF means low frequency and our actual frequency. Okay. And power amplifiers are used for impedance matching. AF amplifiers are used for quality of audio signal. Quality of audio signal. No. Now this AF amplifier and power amplifier both are both are used to increase the signal strength. Both are used to increase the signal strength to the required level. Both are used to increase the signal strength to the required level. The process of selecting required frequency is called as tuning. No. The mixer job, mixing of signal, are also called as heterodyning. Heterodyning is nothing but mixing of signal. Now here, and one more amplifier, RF radio frequency signal means now here RF amplifier. Now what is this RF amplifier? What is the purpose of this RF amplifier? Now this RF amplifier is used for increase high frequency signal strength, because this is high frequency signal strength. Okay, no doubt. Clear or not? Okay, right? All these names and everything, and I am already saying that sometimes it is used Fs or Fc. What is Fs or Fc? Carrier frequency of the tuned station, carrier frequency of the tuned broadcasting station, or a carrier frequency of the modulated signal, or a carrier frequency of the incoming signal to the receiver is nothing but a modulated signal. Okay? Because these notations which we are used regularly in these receivers. Okay. Now first we will see the TRF receiver, tuned radio frequency receiver. First, what is the principle? Principle is important. Operation principle. Now in TRF receiver, listen, the principle is the incoming signal is passed through several amplifier stages, then go for demodulation. What I'm saying? The incoming signal is passing through several amplifier stages, then go for demodulation. Okay. Incoming signal. What is incoming signal? Is a modulated signal. The incoming signal is a modulated signal. The incoming signal is passing through several amplifier stages. Incoming signal means RF signal. Therefore, this is RF amplifier. Increase the high frequency signal strength. The incoming signal is passed through several amplifier stages. Several amplifier stages. Then go for the incoming signal is passing through several amplifier stages, then go for demodulation. This is the RF signal, high frequency signal. To increase the signal strength, here RF amplifier is used, but the incoming signal is passing through several amplifier stages, then it is going for demodulation process, demodulator. So first of all, what is the incoming signal? The incoming signal is a modulated signal. Am I right or not? Now this is the modulated signal. The incoming signal is a modulated signal. If strictly speaking, amplitude modulated signal. Now let us assume this is a 1000 kilohertz modulated signal. What is the meaning of 1000 kilohertz modulated signal? Means here FC or Fs, which is equal to 1000 kilohertz. The frequency of the carrier of the incoming signal is 1000 kilohertz. Now the 1000 kilohertz signal which is you are receiving, you are tuning, you are selecting the 1000 kilohertz modulated signal. Now your tune station here ready to tune a 1000 kilohertz signal, is ready to receive the 1000 kilohertz signal. Okay, that is the meaning of that. So now this is the 1000 kilohertz modulated signal which is coming at the input of the receiver. Now my receiver is successfully received that signal. Okay, so here this RF amplifier is having a tuned circuit. What happened? The RF amplifier is having a tuned circuit. The RF amplifier is having a tuned circuit. Now that's why this amplifier is called as tuned radio frequency amplifier. TRF receiver, tuned radio frequency receiver. Okay. Now this is a RF amplifier consisting of a tuned circuit. Now this tuned circuit will act as a band pass filter. Now we'll see the characteristics of the tuned circuit. Now this is gain versus frequency characteristics. Now see the gain versus frequency characteristics of a tuned circuit. The gain versus frequency characteristics of a tuned circuit is, the gain versus frequency characteristics of a tuned circuit is, this is the resonant frequency. FR or FS. Okay. Now this is gain at FR. Okay. Now this is the upper cutoff frequency and lower cutoff frequency, FH and FL. Now this is bandwidth or pass band. Okay. Now what is the gain versus frequency characteristics of the tuned circuit? This is the gain versus frequency characteristics of a tuned circuit, and you know that now the bandwidth of the tuned circuit is the bandwidth of the tuned circuit, which is equal to resonant frequency by quality factor. The bandwidth of tuned circuit is nothing but resonant frequency. The bandwidth of the tuned circuit, which is equal to resonant frequency by quality factor. Okay. Now see here. The bandwidth of the tuned circuit, which is nothing but resonant frequency by quality factor. The bandwidth of the tuned circuit is resonant frequency by quality factor. Now see here. Now how the process, actual process. Okay. Now how it is selected. Now first we will see. So whenever the receiver is receiving the signal, first the tuned circuit resonant frequency is adjusted. Now see here, the tuned circuit resonant frequency is adjusted. Now the resonant frequency is adjusted to 1000 kHz. Now so students are asking how the resonant frequency is adjusted. The resonant frequency is adjusted because now that is nothing but an LC tuned circuit. For example, FR, which is equal to 1 by 2 pi root LC. Change the capacitor and you can get. So because this is an LC tuned circuit maybe. Okay, for example, this is an LC tuned circuit. Now this is the resonant frequency. By varying a variable capacitance, and this receiver frequency is adjusted and to fix at 1000 kHz. Okay. Now let us assume this axis is 1000 kHz for easy for us. Now the resonant frequency is adjusted to 1000 kHz. When the resonant frequency is adjusted to 1000 kHz, now first it is checking. Yeah, center frequency is 1000 kHz. What is the incoming signal frequency? Yes, 1000 kHz. Okay, this signal is belongs to us. Then it is open the gate? No. Okay, understand? It is not open the gate. When the resonant frequency is adjusted to, see here, when the resonant frequency is adjusted to 1000 kilohertz and a quality factor is also simultaneously adjusted. The resonant frequency is adjusted to 1000 kilohertz and a quality factor is also simultaneously adjusted to 100. Why? The resonant frequency is adjusted to 1000 kilohertz at the same time. The quality factor is must and should be adjusted to 100 kilohertz because this is fixed always. The bandwidth of each AM, this is AM receiver, the bandwidth of each AM station is fixed to 10 kilohertz. Am I not? So the resonant frequency as well as quality factor is simultaneously adjusted in order to maintain a tuning circuit, tuning station. Now this tune station bandwidth should be 10 kilohertz. Otherwise another signal will be coming. Am I not? If bandwidth, what happens? If bandwidth, then the resonant frequency and quality factor is simultaneously adjusted, then the bandwidth is fixed and maintained as 10 kilohertz. Then the receiver will open a gate from 1005 kilohertz to 995 kilohertz sideband. This is the sideband, and see the bandwidth is 10 kilohertz. The bandwidth is 10 kilohertz, and this is upper sideband information. This is upper sideband frequency, and this is lower sideband frequency. When the sidebands are coming, then only the information is coming. Understand or not? Therefore, now the students are asking that, sir, what happens if bandwidth is not maintained? This is LC tuned circuit, for example. So, if resonant frequency and quality factor is not maintained simultaneously, what happens? Bandwidth is changing. What happens if bandwidth is changing? If bandwidth may be greater than 10 kilohertz or if bandwidth is less than 10 kilohertz. Am I right? Not? No doubt. If bandwidth is greater than 10 kilohertz, adjacent channel frequencies are selected. If bandwidth is less than 10 kilohertz, some of the required frequencies are attenuated. Information is lost. Interference will occur. Both. This is the problem which we are facing if bandwidth is greater than 10 kilohertz or if bandwidth is less than 10 kilohertz. That's why the resonant frequency and quality factor should be adjusted simultaneously. Otherwise, your gate will not open and the sidebands will not come. Information will not come. Okay? Information will not enter into the receiver. Therefore, now you construct. Now, this is RF amplifier. Signal strength is increased. Now, demodulator. The incoming signal is passed through several amplifier stages. Then go for demodulator. Now this is the demodulation process. Demodulator. Then go for demodulator. Now the demodulator will convert high frequency to low frequency. RF is converted to AF with the help of demodulator. Now this is AF amplifier. I am already explaining AF amplifier is used to increase the audio signal strength, and this is power amplifier, and power amplifier is used for impedance matching as well as these together to increase the audio signal quality. Okay. Now this is the quality of the audio signal which we are received. This is the quality of the audio signal which we are finally get back. Speaker means audio signal. Okay, now this is a tuned radio frequency. Here it is a tuned circuit. That's why this is called as a tuned radio frequency receiver. Okay, now what are the advantages? First you tell me what is the advantages of this. The advantages of this particular TRF receiver is, the advantage is, now the incoming signal is passing through the incoming signal is passing through several amplifier stages. Am I right? The incoming signal is passing through several amplifier stages. Now this is gain 1, gain 2. So overall gain of the receiver is high. Receiver gain is very high such that sensitivity is completely depends on gain of the receiver. Sensitivity is very high. When the receiver gain is more, sensitivity is high. Okay, sensitivity is very high. Now RF amplifier, high gain, high sensitive. Next, the demodulator will convert RF to AF. Now another advantage is simple circuit. Am I not? Simple design, easy to implement. Okay, and what is the disadvantages? This is the main disadvantage. The disadvantage is by using a single tuned circuit, not possible to vary resonant frequency as well as quality factor. The simultaneous variation of resonant frequency as well as quality factor is not possible. Okay, if it is not possible, if the simultaneous variation of resonant frequency and quality factor is not possible, then what happens? The bandwidth may be greater than 10 kHz or bandwidth may be less than 10 which results variable bandwidth. So the variable bandwidth means greater than 10 kHz, less than 10 kHz, and this is the problem we are facing. If greater than 10 kHz, adjacent channel interference, less than 10 kHz, some of the required frequency components are missing. Okay, now this is the tuned radio frequency receiver, TRF, tuned radio frequency receiver. Generally, this is the way how an incoming signal is passing through the receiver, how this receiver is tuning that particular signal. Now this is the problem what we are faced in TRF receiver. Now to overcome the problem we are facing in a TRF receiver, then we go for super heterodyne receiver. Okay, a small change is here, then means whatever the problem you are facing, that problem if you overcome, then you can get the super heterodyne receiver. Okay, clear or not? No doubt.